This Houdini tutorial is separated by two chapters. The chapter 1, we are going to create a HeightField from scratch, apply noise, some deformations, and bake the HeightField to geometry to send to Karma and render. In the chapter 2, we are going to apply materials, create some lights, area lights, dome lights, and create the final look of the scene. Hello guys! Today we're going to create this moon landscape terrain. For this terrain, I searched some images at Google Images and find these good looking images from the moon. We need to analyze these details. What details have in these images? For example, you can see here are like medium craters, small craters, and the big ones. Subtraction like the noise terrain. We need to create a few steps to create this terrain inside Houdini. First of all, we need to create a simple grid, subtract the big craters, subtract the small craters, and make a noise-like terrain. Let's go inside Houdini and create that. Here in Houdini, first of all, you need to create a geometry. Let's call it Lunar Terrain Effects. Let's go inside this node. And you can see here, when you type height, you can see a lot of HeightField nodes. All these nodes work just for HeightField terrains, landscapes. You can use a lot of these nodes to create operations, to create various types of terrain, like moon, like mountains, like cliffs. First node you need to create is this HeightField node. The HeightField node create a grid, a flat grid on the viewport, but actually is not a grid. This is a volume with 1000 by 1000 by 1 voxel height, which means this is actually a volume. And after that, you can create operations like noise, like subtract, like deform, like painting mask to deform this grid, to shape the terrain that you like to create. The first step, we need to convert this back to geometry, HeightField, because we need to apply some scatter points. There's a lot of points here. We need so much less points. Let's change the global seed to a random value like 100. Let's change the point count method by number of points. I need just a few points like 40. Let's change the global seed. We need more scatter variation here. And use a copy to point nodes. First, we need to create a torus and connect here at copy to points. The idea of creating torus here is like to create this kind of shape here. This torus-like shape will be these small walls on the moon surface. For that, we need to project this geometry in the original HeightField. For this, we use HeightField project, which project this geometry into this HeightField grid. But you need to create some variation in this torus and add some resolution because it looks like it's faceted. To create some variation here, you need to create a randomize node, attribute randomize. And you need to randomize the attribute called p-scale, which drives the size of each instance in the grid. For this, P-scale just have one dimension, float 30, and maximum 100. Cool. But I think the torus is so much thicker. We need to make this torus like thin. For this, we can increase the scale here. I think it's much bigger. Let's reduce the size. Actually, we need to increase the HeightField size. We just need to change the uniform scale like one and a half, and create a much bigger terrain, like 50%, and change the attributes of torus here. Transform the torus and change the scale in Y by 3, and change the torus size and change here by 0.5. This is the first step, but I think this is too uniform and too sharp here. To create a more smooth terrain, more smooth shape in this terrain, we can use a node called the HeightField blur to smooth all this the sharp information here. Let's move around the 21. Another thing we need to do is like subtract from each projected torus like a sphere, because compared to our information here, some craters are deeper than others, and we need to subtract some spheres here. Let's do that. Let's create a checkpoint here to organize our file. Big crater. And for this, you need to copy exactly these nodes and distance a sphere instead of torus. Let's copy these nodes here. Paste here. We don't need to convert this node again, just using. Delete this convert node and connect this converted HeightField to scatter and align. Here we have the same configuration for creating the instance of torus. Instead of torus, we need to create spheres. Let's delete this torus. We don't need that torus here because we already have it here. Okay. We need to move this HeightField blur here and apply the second operation to project these spheres back there in the HeightField geometry. First of all, we need to change this transformation here because these spheres is not looking good. We need a more round sphere, like a smashed sphere, like this. These spheres should be subtracted from the ground, from the HeightField terrain. Let's change the scale 2 by 2. P-scale should be the same from the torus, because we need to project these spheres at the same location which each torus was projected before. Let's use another node project again, HeightField project. Let's connect this here. Let's connect this geometry here and project again. This is an interest shape, but we need to subtract it instead of add. But first of all, let's increase the resolution because it looks like faceted. We need to create more smooth sphere. In this HeightField project, we change the combine method to minimum and disable the heat forces. But here you can see there's a sharp detail here, which I don't like. First, we need to translate the spheres a little bit in the Y position, like 0, 1, 0, 2 is too much, 0, 1, 5. After that, you will create another HeightField blur to smooth out this information and reduce this sharp detail. high field blur. This blur here is around, it should be the same. The full is cool. Let's connect to this checkpoint here. This is the first step. Let's rename this node for more appropriate name like crater projector. Let's go back to the reference and analyze all other information. In these areas here, the terrain looks like flat. There's no noise in these areas. But in these areas here, there's a lot of noise. You can create or paint a mask to flatten some areas and create noise, more noise like in other areas. Let's go back in Houdini and try to recreate that. First of all, you need to sketch some points. You can use these converted nodes and scatter a few points here. Just like 40 points. We don't need so many points here. We just need to create a mask, a random mask to smooth some information and apply noise to another part of the terrain. Let's copy 2 points, some spheres. Let's randomize the p-scale, create an attribute randomize node, connect here and change this p-scale attribute name. The p-scale should be 1 dimension from 100 to 200. We can change the size like 300. And for create a mask that should be used for a smooth operation, we create a node called mask by geometry. We will create a mask by the occlusion of this geometry in the HeightField. That's the information what I need. We project these geometries here. We will use this geometry to create this mask. But this mask is too sharp. We need to smooth out the edges. We can increase the blur here to around 40. After that, we can apply some noise operations here to deform this terrain. Use a high field noise, and rename this to big noise big. It's too big, this noise. We need to decrease the amplitude around 100, which is cool. Okay, if you increase this noise, you can see here, but you don't need too much noise. We need around 100. And create a small noise, use a HeightField noise, and rename this node to noise small. The value of this noise should be around amplitude 20. The element size should be small too, like 50. And you can see the small noise, we have a big noise and you have small noise areas. But this noise should not be applied to all the geometry. We use a mask, like this mask. But here you need to reverse this mask and apply the small noise just a few areas. In another areas should be almost flat. No noise, no too much noise information here, but a little bit more noise in these red areas. Let's create another checkpoint here and call it ref terrain noise. Now we need to create a more noise information in this terrain, because these areas here in the photo reference, let's go back to the reference. You can see that the torus is not like perfect information. We need to deform these areas here to be more terrain-like, like this. You can see these torus here, the walls in this torus. There's a lot of distortion information here. You can do that in Houdini using noise by distort. Noise HeightField distort by noise. And you can see the torus-like have a more interest shape right now, instead just a perfect round information. Let's increase some resolution here in the HeightField just to see more fine details. We can use this node here, HeightField, and change the grid space to 1, and you double the resolution of the voxel. Now you can see more fine grained details in the grid. Right now you can remove this mask, clear this mask using a mask, HeightField, clear mask clear, just to see the white information. That's cool. Now, right now you need to create this another kind of information. These small craters here, like this one is very small, like these 3 here. We need to subtract another layer of small craters from the HeightField to create more interesting details. Let's do that in Houdini. For this, let's go put this node down. For this, we create another node called HeightField Scatter. This node is scatter. We will scatter some points in the HeightField just to copy the small craters. There's a lot of points here. It would be impossible to work in too many points and copy the spheres to subtract in the HeightField. Let's adjust the amount of these scatter points. Coverage should be 0.1. Cool. Reduce a lot of points. Fall off around 0.2. Copy 2 points. Let's copy some sphere here. But the spheres right now is so small. We need to randomize the P scale again. Create a randomize attribute. Rename this to P scale. Lowercase P scale. Change to 1 dimension. Set the minimum value to 10 and maximum value to 30. Here in the spheres, we need to squash these spheres in the y-axis, like 0.5. Reduce the uniform scale to 0.35 and apply the projection to the HeightField. HeightField project. This HeightField node. Let's connect it here. This is projection. You can see that small spheres is adding instead of subtraction from the geometry. We need to change this value in the projection node. We need to adjust these parameters in this projection node. Combine method should be minimum. Disable here hit forces. And you can see a lot of craters, small craters here. Let's disable the occlusion, just to see flat without any shadows. We need another layer of the spheres, another big layers. Actually, we need to decrease the size of the spheres a little bit. Change it here to polygon and change the frequency to 8. We need just to copy these spheres again, these scatter spheres. Copy these nodes, Ctrl C, Ctrl V, and merge these 2 copied point nodes. This layer should be the big ones, the small ones, and this layer here should be the big ones. Let's adjust the size of the sphere here. This should be 1 uniform scale. and translate a little bit in y 0.05. Let's reduce the scatter points in the height field. Alter radius to 3.5, and you can see the merged information. Let's see the project HeightField. That's a lot of information here. It's like a cheese. Let's apply another operation here, noise. But first, we need to select these big spheres and apply some more noise here. Instead of applying noise in the small ones, we need just to apply in these medium ones. For this, we need to mask by geometry. Mask by geometry. And select the big ones. This geometry. This is the HeightField, and just create a mask in the medium size craters. And create a node called HeightField Mask Noise. We will just apply the noise in this mask, the red masked areas here. Let's change the name here. Height. Reduce the amplitude here to. You can see a little bit definition here. Reduce the element size to 10. Now you can see some variation, noise variation in the medium size crater. Let's increase the resolution here to see more information, more fine-grained information in the height field. You can increase these grids by 2, and the final range should be increased by 4,000, maybe 2,000 to 4,000 is a good size resolution for the rendering. Let's change it here in the height field. Grid spacing 0.5. This is a pretty good looking noise from the terrain. Let's organize this network here. Right now, you can apply a erosion in the height field just to add a visual looking good aspect. But I think there's no erosion in the moon because I think there's no water in the surface of the moon. But the erosion of this terrain should be increase the quality of the details. You can freeze here this node at frame 8. Should be enough to add a little bit information in the erosion. Just create more interesting information in the terrain. And you can create another node, HeightField Visualize, just to see the color information applied to this node. Here, we change these colors. First, we need to create a compute range to see the heights of this terrain, and change this just to unsaturated color. Like this brown should be unsaturated. This green should be unsaturated. A little bit dark. Reduce the saturation of this green. Should be decrease the lighting too. That's it. That's all the information that we need. Before we enter this terrain and create like the aspect of the curved surface, like in the final render here, or create a curved information to render this terrain, you can create 2 bands. One band in one direction and another band in another direction. Band. But for apply this band, we need to convert this to geometry because there's no geometry here, just a volume with high detail information. Let's convert HeightField to geometry and bake the point colors and save the geometry to avoid the processing of the geometry when you start to create some renders. Let's call it the cache, lunar terrain, erosion. We just save only one frame, disable time dependent cache, and here in this option we just disable harder based on save and change here to parent and node name. Let's create this cache. Right now you need just to apply the bend in this geometry. First we need to apply this bend like this, start from here and finish here. Let's set capture region here to here. Let's set origin to minus 750. Zero out this to 0. Capture direction 1, 0, 0. Capture length should be 700. Actually, you need to apply deforming, bend deforming in both directions. Then you can change the capture origin to 0. Should be applied from center to border in both directions. Let's see in the perspective. And change it here to minus 20. Cool. You can copy this bend again and change the capture direction to another angle like z-axis. Ctrl C, connect here, Ctrl V, and change the capture direction to 1 here. And zero out the X. Cool. This should be like a sphere surface. Let's create a checkpoint here. Rename this to Alt, Lunar, Terrain, Erosion. This is an erosion version, and you create another version without this erosion. You just need to simply copy these nodes here, Ctrl C, Ctrl V, and plug this visualize node in the node before the erosion, like this. Because in this version we don't want erosion. We can visualize the render without the erosion. And save the geometry. We can rename this to Alt Lunar Terrain Non-Erosion. This geometry here, this lunar terrain here, should be rendering in Karma. Let's create a loop network. And rename this to Look Dev Terrain. Let's go inside this node and create a SOP import node. Let's rename this node to Terrain Erosion. Change the sublayer here to Copy SOP layer and try to find our reference. Should be this Alt Lunar Terrain Erosion. Accept. The geometry is imported here. And you can start apply shaders and create some lights. Let's first create a camera. Select here camera, lock the camera view, and try to find a good looking perspective. I think that's cool. That's enough. Let's create a Karma node. Rename this to Lunar Terrain Erosion Built. Connect the camera here in the Karma node and disable some attributes here. We don't need depth of field, don't need motion blur. Let's change the resolution here to 1920. If you have a good graphics card, you can change to XPO. Let's decrease the sampling to 9 and create an area light to create a dramatic effect like in the render here. Area light from the left to the right to create a nice shadow fall off. Let's connect the first area light here. Let's look through light area lights. Let's move this light to the origin. Let's zero out the rotation tool. Look through light. Let's adjust the light position here. I think this is good enough. Let's see the camera and see what happened in the Karma render and see the position of the light. The light too small here. Let's increase the size of the light, like 500 by 100, and change the position here. Let's increase the intensity to exposure to 7. That's a good start. Let's move this light here. Rotate. Let's look through the light. And see the camera again. That's nice. Let's increase the light intensity to 100. Too much, like 10. Still too much, like 1, like 2, 3. That's enough. I think there's too much information here in the light. Let's normalize the power of the light, this light. But we need to increase a lot of this intensity, like 10,000, 100, maybe 10,000, 100, 6 in the exposure, like 7. Let's adjust a little bit the position, just to curve surface, to see more fall off in shadows, like this. Let's put a dome light and reduce the intensity a little bit, like 0.2. I pick up some HDR here. We can use that to apply some HDR information here. Text, HDR, Moonless Gulf, increase intensity 1, too much, 0.5, I think it's enough. For the shader, we need to apply the shader. Let's disable here the Karma and create a material library and create the shader here. Karma Material Builder, Karma Lunar. Let's go inside here and adjust some few parameters. First of all, we need to pick up the color information for the geometry and applying the base color here using this node, Material Geometry Color, and apply here to the base color. Let's increase the roughness a little bit, like 0.5. Let's apply the shader to geometry. First, we need to create another node, Assign Material. Click this node here and Autofill Materials to fill this information with the current shaders. And assign material, we need to select the terrain here and select the material here, Karma Lunar. Cool, let's see the Karma render here. I think it's too white. We need just to decrease the dome light or the R light. I think exposure should be 5, 6, much better. Let's reduce a little bit the intensity of the dome light. If you want to change a little bit in the shader, we can go there and change the roughness, make more metallic or make more roughness. I think this value should be around 0.5, the same. Let's decrease the color a little bit, make more darker, 0.7. And this is the final render. I created the camera here and I created the camera here. Make some little animation. That's the final result. That's the final result of the rendering. That's it, guys. We create a moon landscape using Heightfields in Houdini and rendering Karma Solaris. Thank you, guys. See you next video.